All right, let's talk specifically about drag forces during cycling. So we'll use our general equation for drag force from fluid dynamics, 1/2 rho CDA V squared. You should know these parameters. Rho, density of the fluid. In this case, we're talking density of air. Specifically, CD is that parameter that tells us how well the fluid moves over the object. Coefficient of drag, how well fluid moves over the object. This is due to the shape, due to the surface characteristics, due to the fluid characteristics, how it interacts with the surface, but these are two big things that we need to deal with. The next parameter is A. This is the frontal area. This is the area, the cross-sectional area, perpendicular to the flow of the fluid. Perpendicular to the flow of the fluid. So from a cyclist perspective, if the wind is coming from the front of the bike, we would look only at the frontal area. We would take a picture of the cyclist and we would draw an outline around the picture from the front view of the cyclist. And that area would be what goes into this part of the equation, okay? If the wind's coming from the side of the person, we need to look at that area perpendicular to the direction of the fluid or air in this case. And then finally, V is velocity of the fluid. How fast the air is moving over the object. It's not ground speed. It's not how fast the bike is going. It's how fast the air is moving over the object. All right, so something that's really important is in cycling, we don't calculate CD and A separately. Typically, we don't. All right, there may be times that we do, but sometimes they're hard to separate out from each other. And that's because if we change the frontal area, sometimes we end up changing the shape of the object, which will influence coefficient of drag. So for example, if you're riding and you're in an upright position, your frontal area would be big and your coefficient of drag would be some number. But if you drop down into a low position, you drop your head down, you get into an aerodynamic position, your frontal area goes down. That change in shape also influences CD. So what cyclists will typically do is combine these two terms into one term, CDA. That CDA, you'll hear it said that way a lot, is the two parameters combined into one. So you may hear a cyclist talk about his or her CDA being a 0.17, which is really, really good, versus a CDA of 0.28, all right? Those are very different numbers, and those describe these two components combined. And those two components go into this equation right here. Okay, so drag force is a function of 1/2 the density of the fluid, in this case density of the air, CDA, the shape and surface characteristics of the object, and then how fast the fluid is moving over the object squared. Okay, now density of the fluid, that's influenced by things like humidity or altitude. Okay, this will influence, those two things will influence how dense altitude, my spelling's terrible, how dense the air is. That will influence rho. CDA is influenced by a whole number of factors. Your helmet, the skin, or this could be the skin suit that you're wearing, or the clothing that you're wearing on the bike, whether the clothing is tight or whether it's loose, whether or not you are wearing glasses or a face shield, or how well the air moves over the fabric. So the actual fabric will play a role in CDA. This is influenced by body position on the bike. It's influenced by the movement of the legs when pedaling. So all sorts of things that will influence one or both of these parameters collectively. Okay, so that's drag force and the factors that will influence drag force during cycling. Oh, you know what? I probably need to go ahead and write out the factors that influence CDA, just so we have those, or some examples. So CDA, for example, clothing, tight fitting, loose, will influence CDA. The fabric, whether the fabric's wet or dry, body position, aerodynamic position versus an upright cyclist, equipment like the helmet, the shoes, socks, now it should be under clothing, I guess. Helmet, shoes, socks. Yeah, we actually will put on shoe covers to minimize. We put a piece of fabric over the shoes and the socks to minimize any resistance. Actually, the pedals, the frame, and the frame can be probably really especially the fork. Yeah, and the different tubes on the frame, the wheels, and I'm not going to put tires here, but I could put tires down because the tires actually do influence the drag force of the wheels, the spokes on the wheels, any wires that are exposed, anything where the wind, the air can hit on the bike rider system. Okay, so those are the main examples of factors that can influence the, and let me put a sub bullet here. It's not only shape, but it's also surface characteristics that influence CDA for all of these items related to biking. Okay, thank you.